Hello everyone. So today I'll be solving the educational round 181. I'll be sharing these solutions with you. And so let's immediately start with the first problem. The problem name is difficult contest, and the problem basically says that we are given a string S, and if the string S has one of these two patterns, so if it either has FFT or NTT as a contiguous substring, then the contest is termed as difficult. So if we can remove these patterns or eliminate these patterns from the string, then we have to do that, and we have to print the eliminated or the difficulty free string. So if we take a look at the test cases, FFT is a direct match to FFT, so we can have FTF, so we can just swap these two and have a valid string. And in this you can see that there is NTT, so if you swap this, then also this confirms. So now a very simple observation to this problem is that T comes after F and N in alphabet. So if you put T before F and N in the string, then you can never have such a pattern. So basically sort the string and reverse it, or basically sort the string in the reverse order. So T will always come before F and N, and you will never have such a pattern. So if I move to the solution of this, then this is a pretty straightforward solution here as well. You can see that I just am sorting the string, and then I'm reversing it and printing it out, and it gets accepted. So now let's move to the second problem. If there is anything you want to say for this. Okay, so now let's move to the second problem, which is left and down. So the problem says that we are given an infinite grid, and we are also given 2 points A and B on which our robot is standing initially, and we want to put the robot to point 0, 0. Now here you can see that A and B are both greater than equal to 1. So that means initially the robot won't be standing on the cell 0, 0. It will be standing on any cell other than 0, 0. And what we can do is, in one operation we will be given an integer k. We can choose two integers dx and dy. The values of both of these should lie from 0 to k, and we can basically move the robot left by dy and up by dx. And so basically in one operation we can change the coordinates of the robot from x comma y to x minus dx comma y minus dy, and such an operation will only cost us one coin, or one cost just once. Other than that, otherwise we will just be getting like 0. So for example, if we choose dx equal to 1 and dy equal to 1, and we repeatedly do this operation, we will just be getting a 1 cost, because that cost will only be incurred in the first move, and afterwards we will incur a 0 cost on the subsequent same dx and dy. And we can also note here that like dx and dy and dy and dx are considered different, so we will be getting different cost if obviously dx and dy are not equal. Now the solution for this also is not very complex. So the one observation to be made here is, if let's say we have A as 4 and B as 8, so what we can do is, let's forget about k first. So if we want to take any number, then we will choose dx as 4, dy as 8, and in one operation we will be done with the procedure. But we are given k. So here you can also see that the maximum number of operations required will be 2. They won't exceed 2, and this can be proven. You can simply take 0, 1, dx and dy as 0, 1 and 1, 0. So these two will incur you 2 cost, and you can, like, this is trivial that they will be able to traverse any points. Now, so this is proven. This is, so let's solve this on the text editor. So what I'm saying is that the max cost can be at most 2, and this will be basically, if you choose 0 1, so this can cover all points in like column wise, and 1 0 can cover such points row wise. Now, when can the answer be 1? We have already proven that the answer cannot be 0 because a and b are both greater than 1 or equal to 1, but the answer can be 1. So when k, let's say, is 2 and a is 4 and b is 8, so what we can do is we can take dx is equal to 1, dy is equal to 2, and in 4 steps we can cover 4 operation x wise and 8 operations y wise. So what we basically are doing is we are taking the GCD of a and b and we are dividing that by, so let's say this is g, let's say this is g, so we are doing a is equals to a divided by g and b is equals to b divided by g, and if the max of a comma b is greater than, is smaller than equal to k, then we will output 1 as the answer, because obviously we can take that. So why max? Because obviously the range should lie in k. So if in this example when a was 4 and b is 8, then we got the GCD as 4, we divided a by 1, a by 4. Basically you can repeat dx 4 times to get a, and dy 4 times to get b, and since these both are lying in like they are both like smaller than equal to k, so our answer is possible. So if we see the code for it, then you can see here this I did because I wanted to ease implementation out, so I am forcing y to be greater than x, and this is basic. I could have, like, here I am saying g, I should have taken that. So this GCD is basically g for original x and original y, and simply I am doing this is extra, this can be removed, but if the greater element is like smaller than or equal to k, then we can reach 0 comma 0 in one operation, otherwise we will have to make 2 operations. Okay, so if someone is watching the stream and has any question, you can ask me that, but otherwise let's go to the next problem, which is problem C. Okay, so C says that we will be given a range L to R, and in that range we have to find the count of numbers who have the smallest prime factors having digits digits greater than or equal to 2, like at least 2 digits the smallest prime factor should have. So if you, we'll need the text editor for this, so let me show you what I'm saying. So okay, so since we have to find, since we have to find the number of numbers between L to R, numbers in L to R having smallest prime with digits greater than or equal to 2. So you just naturally ask the question that which primes have digits 1. So these are 2, 5, 2, 3, 5 and 7. So 2, 3, 5, 7 have digits 1. So if you can find out the number of digits, number of elements from L to R, those not having any of the 2, 3 or 4, 5 or 7, then you can get the number of such like number of what we have to find out. So let's call them beautiful numbers. So this basically is a simple implementation of principle of inclusion and exclusion. So you have to just, so let's say we have a function val which takes an integer x and gives us the and let's say the numbers having any of these as prime, as factors, as bad. So okay, so the val, let's say val x is a function that will give you bad numbers, count of bad numbers from 1 to x. Then our answer will be, so then what will be the count of bad numbers in range L to R? So this will be simply a value of R minus value of L minus 1. This is the observation. So like principle of inclusion and exclusion says that and how will it be used here? So if you want to find from 1 to x how many numbers are divisible by 2, so the answer is simply 2 x by 2. So similarly for 3 the answer will be x by 3, for 5 the answer will be x by 5, and for 7 the answer will be x by 7. Now finding these 1, 3, 5, 7 individually, we would have double counted a combination. So sorry, yeah, this should be 2. So finding these, we obviously would have double counted the combination. So we would have double counted 2, it's 6. So then the divisible by 6 are this, and so this is how the principle of inclusion and exclusion works. So if you can just see like let's just show you principle of inclusion, exclusion for variables. So if you can see, basically this is it. Like here you can see this individual minus 2 at a time plus 3 at a time minus 4 combined. So this is what the principle of inclusion and exclusion is. So now let's move to the code of this question. So what I'm doing here is let's first show you the main function. So I'm just taking input L and R, then from L to R the total number of elements from L to R are simply R minus L plus 1, and I am just subtracting those which bad numbers. I'm basically subtracting the bad numbers from this range, so that will be my answer. Now let me walk you through the val function that will give you the count of bad numbers in x from 1 to x. So I'm just creating an array of prime factors 2, 3, 5, 7, and I'm creating a result. This result will represent the number of bad numbers in 1 to x. So the mask is of 4-bit. 4-bit mask can have a max value of 15, and this will represent what I'm including and what I'm not including. So like simply if I show you in an example, so if the mask is 0, 0, 1, 1, this is 3. So this is the 3, 3, 2, 1, 0. So my 0th, okay, and 7, 5, 3 2. Okay, so my 0th bit corresponds, so my 0th bit will correspond to the 0th index, and this is 1. Since this is 1 here, I will include 2. My first bit will correspond to 3. So now if this is 1, then I will include 3. So basically whatever is 1 here, I will multiply all those numbers and include them. And so this is what exactly I'm doing here. I'm just going through all the bits and I'm checking if the current bit is 1 or not. If it is 1, I'm basically multiplying it, and I'm also tracking a count, so that as you saw, when we are combining even numbers, so 2 into 3, the even number of combinations are getting subtracted and odd are getting added. So like let's walk that through again. Inclusion, exclusion, 4 variables. So if you see that picture again, see, if I take 2, 3, 5, 7 individually, they are all being added. If I'm taking 2 and 3, 3 and 5, 2 and 5, so on. So if I'm taking 2 at a time, they are being subtracted, everyone. Similarly, when I'm taking 3 at a time, they are again being added. So when the number of elements being combined are even, they are being subtracted. See here, 2 subtracting, 4 is being subtracted, 1 and 3 both are being added. So that is what I did here as well. If the count is odd, then I'm adding it. If the count is even, then I'm subtracting it. And this is how C will be solved. So if there is any doubt in C, then I'll take that up. Otherwise, let's move to problem D. Okay, I guess no one is watching the stream right now. So let's move to the problem D. So I don't know why, but D was it was pretty challenging for me, because initially I went in the direction of DFS here. So I was just doing a DFS, and then I realized this was wrong. But by that time, my 1 hour was already elapsed for me. But then I thought about DP for a few, and then after I thought about DP, it was easily solvable. But this was actually a pretty challenging problem. So the idea is very simple here, basically, and obviously this is modulo arithmetic, so everything you have to make different, either you make functions, or making functions is very, so making functions of multiplication, division and subtraction, addition in modulo arithmetic simplifies things. Otherwise, manually tracking all of that is very difficult. So that is why I made functions. So inverse is basically finding an inverse mod something. Then multiplication will multiply 2 numbers, sum will add 2 numbers, sub will subtract 2 numbers, divide will divide 2 numbers. And yeah, so let me walk you through the logic. So first thing I did was I sorted the ranges, and while sorting the ranges, if you observe, so let's walk through the code. Not walk through the code, let's open it in the text editor so that we can explore at least what the logic was. So if you see, if you sort these ranges in increasing order, it will be easy to calculate the prefix probability array, and this is pretty simple. So let me first solve this example. So this is 1 2 1 3, 1 2 1 3, then 1 3 2 3, then 3 3 1 2. So if you see here, then 1 2 3, these are the segments or the cells I have. And when I'm choosing 1 2 when I'm choosing the first, like basically when I'm choosing the first range, my probability of it taking that is 1 by 3. But in this I have to disclude the second, so I have to disclude this because 1 and 2 can only be covered by exactly one segment, so I have to disclude this. And so the probability to disclude this is 1 by 3 as well, basically 1 minus 2 by 3. And then I have to include the last number, so 1 by 2, and obviously flip that number as well, so 1 by 2 into again 1 minus 2 by 3. But I can also simply include this, so again this will be 1 2 by 3. If I want to include this, then I have to disclude the first and I have to disclude the second as well, so 1 by 2, yeah, or 1 minus 1 by 2. So if you see, the answer will be 5 by 18 as given. If you solve this, the answer will be 5 by 18. And so from this, like you can see that we have to track some kind of prefix array so that we can get these, like these are the important thing here, because this is like 1 by 3, the direct probabilities we have, but we have to pre-calculate somehow this 1 minus 2 by 3. So all the probabilities that we will switch off, all the segments that we will, if we want to include one segment, then all the overlapping segments have to be switched off, correct? So if they have to be switched off, their complementary probability will have to be taken. So basically the chances of them not occurring will have to be taken. So that is the point of doing this here. And this is simply, like if you see, these probabilities are simply q minus p divided by q, like simply that. Okay, so now let me show you how I'm calculating the prefixes. So the prefix of 1 is basically, this is basically q minus p divided by q. So this is basically what I'm saying, and then I'm multiplying it overall. And why is it necessary? I will show you in some time. So basically why prefixes are needed here is, so the solution regarding dp involves dp, okay, and basically the dp of I will represent the dp of I, yeah, basically it will represent the, what do we have to find here, yeah, probability, the probability to reach m plus 1. This is what my dp represented, the probability to reach m plus 1, and the answer will be dp of 1 from I, m plus 1 from I, and the answer will be dp of 1, obviously, because we have to reach the last element from 1. Everything needs to be covered, right? So now if you see on every segment sorted, like if we have sorted the segment, then you can see that if we just do, let's say the segment is u, v, p and q. So from u to v, you will incur a probability of p by q. So if you say that find all such segments having u in them at least, and find all such segments having v in them, then you can calculate the total probability, like I mentioned, like this thing in all of them by using the prefix array, right? So so basically the dp of u will be dp of v plus 1 into that, like the probability of the current u into not using the other u's or the other overlapping segments. Like this was basically the main idea. I mean, if there is any and the trivial case will be that, like the base case will be the dp of m plus 1 will be 1. Like from m plus 1 you can always reach m plus 1 with a single, like one probability, right? So and otherwise all of them will be are initialized to 0. And I mean, if there is any problem in understanding the transition state, then I'll go over it again. So dp of u represents the probability to reach the m plus 1 segment or reach out of the segments or cells from u. So that will be dp of u. So from u to, from any segment, right? I defined segments, right? In this segment, currents, if the current segment is u, v and p and q, then you can reach from u to v and then u to v and whatever is the probability on v plus, like v plus 1, you can multiply that probability by the current u. So basically if I take the current segment, what is the probability for the current u? So this is p by q simply, and this is the probability of not using all the other overlapping segments. So the segments that are overlapping must not be used when we are using the current segment, and overlapping segments can be found out easily. We can find out the lower bound of u. So basically so we have to sort the segments, right? So in the sorted segment, if we find the lower bound of u, we will find all the elements that have left range greater than equal to u. So we will find the left range, and right range can be found out by finding the upper bound of v minus 1. So that will be the right range. So in this range we have to take all of these, and this will be the overlapping segment. So let's walk through the code now. Yeah, let's go here only. So I mean, this is just these are the modulo operations. It makes things easier. And dp of m plus 1, as I said, is 1, because to reach from m plus 1th state to m plus 1th state, we can definitely reach that because we are already there. So that is why the trivial case is 1. And how am I calculating the prefixes? Prefix of 1 basically is the first prefix of 1 represents the first probability, and then so on. I'm just multiplying all of those. So as you can see, I'm just multiplying prefix of I minus 1, and then this is, if I write it in a comment, then you can see that. See, v of I minus 1 and 3 is q, because q is the last, right? Q is the last. This is 0, 1, 2, 3. 3 is q. 2 is p. Again 3. And I'm dividing this time. So this is q. This is basically 1 minus p by q that I showed. Like we have to find out these probabilities combined. So now I'm just multiplying all of those so that I get a prefix array. And I'm here LV is basically the left. So I created this array to ease out the binary search, and I'm just pushing the u part. Now this no prob, so I'm going from backwards obviously, and this no prob is the probability when I'm not using all the other overlapping segments. This no prob will represent that. How am I calculating it? I'm just finding out the left range, which is the upper bound of this, and the right, which the lower bound, and the right is the upper bound. And left should be basically this is left and right are remaining untouched here. It's a neat trick to just calculate the prefix as I've calculated it. So otherwise, I mean, if I have to take the, if prefix was 0 indexed, then this won't work, but otherwise here it is, it will work because I don't have to subtract 1 from it, which we usually do. We can just calculate it like so. And left, I don't have to subtract 1 from left because this is actually 0 indexed, because LV is 0 indexed. See, LV is 0 indexed. So no prob is also divided by the current, because obviously this so no prob is the basically the okay, let me again show you what will prefix look like. So prefix looks like this: some number 1 into some number 2 into some probability, let's just say some probability p1, p2, p3, so on, pn. And so from left to r to right, it will be p of left minus 1, sorry, p of r divided by p of left minus 1. So this is what I'm doing here. This is what I'm doing here. You can see I'm not doing left minus 1 again, because this is a zero bound, this is a zero indexed array, so left will be obviously 0 indexed, so minus 1 already, and right is upper bound, so right is already giving me plus 1. And also, like, this line, what it does is it removes, so this line removes the current segment from the no probability. This is important because whatever the bound, whatever left to right we got, this will also include our current segment, correct? Because we are checking the 0 and n, and current segment conforms to this range. So current segment should also be removed from it, and so that is why I'm removing. Like, this is again p divided by q, p minus q divided by q minus p divided by q is being removed from this range. And here you can just see this. Let me just write here, like, what is this? This is basically this. Let's start from this thing. So this thing is p by q, and no prob is the probability that, okay, so no prob is basically the, again I'm like repeating, but it's the probability that all the other overlapping subsegments are discluded. Only then we will be able to ensure that exactly one segment remains. And here you can just see that they are being multiplied, and this I already told you that VP of I of 1 plus 1 will be multiplied by this. So basically this is V plus 1. This is the UV wala V plus 1. Okay, the V plus 1 from the UV example here. This is it. This is what I'm multiplying. And yeah, and I'm also adding it to the current, because multiple possible ranges are, like, multiple ranges are possible, multiple combination of segments are possible, so that's why I'm adding it. And then my answer will be dp of 1, and this worked. I mean, so yeah, so I mean, if there is any doubt here also, I mean, I'm okay to answer that. Otherwise I will end the stream now, and yeah, I guess that's it. So okay, I guess I'll end the stream. Thank you for watching, everyone. Bye.